Hello, my name is Kevin Lamb. I'm the Group Product Manager for Azure Messaging. Today we're going to talk about what's new in Azure Messaging. Before we get started, let's start with the platform building block patterns of messaging services out there today. Cloud-based messaging platforms typically support one or more building block patterns for asynchronous event message handling. This is the discrete event router, which is for push-style distribution of discrete events to serverless workloads or other messaging infrastructures. Discrete events are the types of events where you want to react to each event individually. For example, when a new file is dropped in a folder and you have a process that needs to pick up that file and do some processing with it. There is the queue pub sub broker, a pull-style queue-based transfer of jobs and control via message queues and topics. This is the classic message broker that typically has capabilities like order delivery, dead lettering sessions, message locking, transactional transfer, etc. Messages consumed once and then destroyed. There is the event stream engine, which is a partitioned high-volume tape drive style sequential recording and unlimited pull-style reads and rereads of event streams. Typically used for transferring a time series of events, such as temperature, speed, set of things clicked on, geolocation, etc., that can be consumed as a sequential log. Then there's the event stream processor as an extension of the streaming ingestion capabilities. Stateful transformation and analytics of event streams yielding an event stream and discrete events as its continuous output. Stream processors can facilitate both operational stream processing and analytical stream processing, doing enrichment, transformation, and filtering, as well as window aggregates for sum, averages, min-max over a period of time, and include machine learning as part of that processing. As we look at the Azure Messaging platform, we have a complete set of capabilities across these platform types, where we have a discrete event router as Event Grid, and a queue pub sub router with Azure Service Bus, and an event stream engine with Azure Event Hubs. And our event stream processor is the Event Stream Analytics. We see that about 75% of all of our enterprise customers use at least two of these brokers together because the patterns that they use across these services and their custom-built applications require different capabilities. It's reliable. We work at over 5 or 6 nines of reliability every week. It's scalable. You don't have to worry about how we scale. We handle all that scaling in the background. They're all platform as a service capabilities. We handle trillions of events every day. And we're standards conformant. We work with cloud events, support MQP, MQTT, the Kafka API, and JMS across our set of brokers. Now let's go into what's coming for each of those services. First, let's start with Azure Event Grid. As an overview of Azure Event Grid, Azure Event Grid is a fully managed, scalable event router. It provides event dissemination from event sources, such as Azure services with a system topic. Partner topics have SaaS services, if you want to get messages from SAP, for example. Or custom topics for your custom apps and custom events where you want to be a producer yourself. Event Grid provides push delivery, so you can push to a webhook that then can invoke a function or a logic app, for example, or you can send it to an event hub or a service bus to get queued. It has reliable delivery retries, so even if it initially fails, we'll continue to retry for over 24 hours. And then if it finally can't deliver that message, it gets dead lettered so that you can go interrogate it later. Azure Event Grid is evolving as a pay-as-you-go elastic pub sub broker with support for MQTT and pull semantics. So this is something really new for Event Grid, where we're enabling different capabilities with Event Grid. Event Grid is our modern elastic event broker in the cloud. We're going to add pull delivery. So today we do push. Now we'll be able to get the messages at the rate that you want to consume them. We'll provide namespaces, which is an entity collection so that you can manage all of your different topics together. It'll provide high throughput with over 100 megabytes per second. And it's going to support MQTT both version 3.11, and version 5. We'll have flexible topics, so you can decide how many topics you want and the paths and patterns that you need to utilize. And we'll be able to route those MQTT events to different Azure services. One of the big aspects that we're adding to Event Grid is support for an MQTT broker. It enables your clients to communicate on custom MQTT topics using a pub-sub communication model. As I noted before, it's going to support MQTT v3.11 and version 5. It will have custom topics with wildcard support. So it allows you to create the hierarchy of topics that you want. They're dynamic topics with wildcards, so you can have a vehicle with a vehicle ID and then listen to all events from all vehicles, even if that's in the topic path. Pub-sub messaging models, so you send an event once and then multiple consumers can get those same events. We'll have device-to-device, cloud-to-device, and device-to-cloud communication patterns. So you can talk to your devices and devices can talk back to the cloud. We'll have flexible and fine-grained access control models, so that allows different clients to determine, the operators to determine which clients can access which topic paths and topic patterns. We'll be able to route to Azure services and custom webhooks. We'll have persistent sessions. So persistent session allows a client to connect, receive a set of messages, disconnect, and come back, and that subscription is still active and will continue to receive those messages. Those messages in between won't be lost. We'll have quality of service levels 0 and 1, and we'll support X509 certificate authentication for your clients. Next, let's talk about Azure Event Hubs. We're super excited to announce the private preview of geodata replication. Today, Azure Event Hub supports geodata replication only for metadata. And now with this private preview, you'll be able to have the namespaces across multiple regions and the data being replicated across those regions. The geodata replication will go not only to a secondary, but can have multiple secondaries. So you can have multiple secondaries all around the world. We'll have a stable namespace so that you can talk to one FQDN, and when you switch over from a primary to secondary, that FQDN won't change. So that means your clients can consistently talk to that namespace without having to be affected by a state change between those primaries and secondaries. We have byte-to-byte replication of metadata, event data, and consumer offsets across those georeplicas. We'll also have a consistency, which is like your RPO of sync or async. So you can determine that once a message is sent, if it's sync, that means that the secondary will, at least one of the secondaries will receive it before we come back and commit that the message is in our system. So what else is new that's coming with Event Hubs? We talked about geodata replication. We're also going to add JSON schema support in our schema registry. Today it supports Avro, and now we're adding the JSON schema support. We're also extending our Kafka capabilities so that Kafka compaction feature is now generally available. With that means we also get the ability to have Kafka Connect and Mirror Maker 2 as generally available and supported capabilities from our Kafka endpoint. You'll be able to capture to ADX. So now we can capture in Avro format to a storage, but then with this new capability, you'll be able to capture directly into Azure Data Explorer. So then you'll have a live indexed set of events so that you can query ad hoc in real time. We're adding a data generator so you can push sample workloads into your Event Hub. So you don't have to go and whip up a client on your own to see how your Event Hub is working or the downstream components are consuming them. And finally, we're adding captured managed identity. So for capture, we're enabling you to utilize managed identity so that you can now use storage accounts that are across distinct subscriptions. Now let's see what's new with Azure Stream Analytics. First, let's go into a demo of what our no-code designer looks like with Stream Analytics and Event Hubs.
I will show you how you can create your Stream Analytics job using no-code editor. If you go in your Event Hub instance, in process data, there are multiple templates available to you where you can process your Event Hub data using no-code drag and drop experience. There are templates where you can build real-time dashboard with Power BI, or you can capture your data to ADLS Gen 2 in Delta Lake format, or you can just enrich your data and ingest to Event Hub. You can also transform and store data to SQL DB, or you can filter and store data to Azure Explorer and various other formats. We also give you a blank canvas where you can get started without templates as well. For this demo, I will be walking through how you can create this query in no-code editor. The intention of this query is that let's say you need to count how many number of vehicles that enter a toll booth. And because a highway toll booth has a continuous stream of vehicles entering, those are entrance events and they're analogous to a stream that never stops. To quantify the stream, you have to define a period of time to measure over. So let's refine the question further to how many vehicles enter a toll booth every 3 minutes. And this is commonly referred to as the tumbling count. So from the list of templates, I will select the Power BI dashboard template, give it a name. Your Stream Analytics job is created within less than a minute. You confirm your Event Hub details. Within a few seconds, you will see the incoming data preview. So here I have toll booth data where the car model, entry time, state, toll amount, tag, toll ID, etc. is given. You land into this no-code experience, and there are various inputs that you can add, outputs, or operations. Inputs is the source where your real-time event data is present. Output is the destination where you want to send your transformed real-time data. So we have support for ADLS Gen 2, Synapse, Cosmos DB, SQL Database, Event Hub, Azure Data Explorer, and Power BI. There are various operations or transformations available for you as well. You can filter, manage fields, aggregate, join, group by, union, or expand. For this template, manage fields is available, but I want a combination of group by and then manage fields to match up with the SQL query I showed you. Here I have combined two transformations, group by and manage fields. I will set up my transformation where I can specify what kind of aggregation I want, average count, minimum, max, etc. I will also set up my time window over which I need the aggregation, and this transformation will help me rename some of these fields. I have combined the two transformations, group by and manage fields. In group by, I have assigned a count aggregation over toll ID and a tumbling window of the duration. And from the incoming data, I just want a toll ID and system time, stamp, and count, which I've renamed to these three fields. And I have set up the Power BI destination where I want to send my transform data. I did the whole pipeline without writing a single line of code. So I will save my job and start it. My job is now running and I can see what is the Event Hub data that was coming in and what's the data that's going in Power BI. I can also see different metrics where I can monitor the health of my Stream Analytics job. Now I navigate to the Power BI dashboard that I have created, and you will see that the data is refreshing based on the duration that I have selected. I've created a dashboard for cars which are passing the toll booth, and I did this without writing a single line of code. Thank you for watching.
One of the things that Azure Stream Analytics has always provided is a low-code capability using a T-SQL-like language called SQL that allows you to create SQL-like statements to do your stream analytics processing against the stream of events that are coming in. We had introduced last year a no-code editor that was provided in the Event Hub's portal. Now we're bringing that same no-code experience to the Stream Analytics portal and adding new sources for that designer. So the experience provides a canvas that allows you to connect to input sources to quickly see your streaming data. You can then transform it before writing to your destination of choice in Azure. It gives you a data preview, so you get to see all the events that are coming in, and a runtime set of runtime logs and metrics, so you can see the health of each of the steps in that flow. We're also providing a job simulator in the portal and VS Code. So in the portal, it's going to be coming out in preview in VS Code. It's been out in VS Code for some time, and we're going to make that generally available. The job simulator, before you actually deploy into the cloud, will allow you to simulate the job within your tool And then you get to see the parallelization of your job. So the number of streaming units that you've created against the number of replications and how the job is created, and to ensure that you're creating the most efficient type of job. And then we'll give you hints for how you can either adjust your job or adjust your scale units to make it as efficient as possible. What else is coming with Stream Analytics? Something really big that many customers have been asking for is a new pricing model. We are making the price 30% to 80% cheaper, depending on how you're going to consume it. And we're going to be introducing a SUV2. We'll have a simple upgrade. Just select the new SKU for your job and restart it, and you're now working on the new cheaper SKU. There's a simplified scale model. Before, you needed to understand what the SU mapping was to workloads that you were doing. Now it has a linear upgrade path for each of those streaming units. Virtual networks for jobs. Before, we had virtual network support in the dedicated offering of Stream Analytics. Now we're bringing that into the standard offering. So now you have enhanced network security for your standard ASA jobs with virtual networks. And so that's coming in public preview. Kafka input and output is coming in private preview. So now you'll be able to take your Stream Analytics job and communicate to a Kafka cluster. That Kafka cluster can be on-prem, utilize that new virtual network capability in your standard job, and consume those events from Kafka cluster, as well as send events to a Kafka cluster. Delta Lake output support is going to be generally available. Delta Lake is a common Parquet format that's used in data warehousing. And with Stream Analytics jobs, you can select the output format as Delta Lake, and without any code, we transform it into that format for you. We're also going to be supporting larger batches in that work as well. We're adding support for exactly once delivery. So that's both to Event Hubs and ADLS Gen 2. So then you don't have to worry about, as your jobs stop and start and stop and start, if where you got left off, if you're going to repeat any of those events, we'll do exactly once delivery and handle that for you. We already talked about the hosted no-code editor that's in the ASA portal and the job diagram simulator. But we're also going to make generally available the auto-scale. So today, auto-scale allows you to automatically scale your streaming units for jobs based on metrics, and now we'll make that generally available. We're also integrating the Event Hub schema registry into your jobs. So now you can have schema validation right within your job and ensure that the events that you're getting are in the format that you expected them as they are in the schema registry. We're also doing improved troubleshooting for better errors and logging of all the events that happen in your streaming job. Microsoft Fabric event streams. So this is new and exciting. You've probably heard about Microsoft Fabric by now. It's the data platform from the era of AI and provides a complete platform for all analytics workloads, open at every layer with no proprietary lock-ins. Fabric provides a unified intelligent data foundation for all analytic workloads and integrates Power BI, Data Factory, and the next generation of Synapse to offer customers a price, performant, and easy to manage modern analytics solution. Every analytics workload works seamlessly with OneLake to minimize the management, time, and effort, eliminating data movement and duplication. Fabric reduces the pain of integration and facilitates better collaboration with the solution that makes it easy to connect and use the different analytics tools for your teams. It's open at every layer with no proprietary lock-ins. Now you see the different workloads at the top of this image, the Data Factory with Synapse, warehousing, data engineering, data science, real-time analytics, Power BI, and Reflex. One of the things we're excited to talk about today is the addition of streaming to the real-time analytics workload. So today there's torrents of events that are happening out in the world. And we want to get that torrent of events landed into our fantastic Microsoft Fabric destinations, so a Lakehouse or a KQLDB or to a Data Mart, to all those entities that we can find in Fabric today. But how do we do that? What we've done is we've set these sources as an event stream sources, so you can have an Azure Event Hub, Azure T Hub, change data capture information, information from IoT devices, Kafka events, and we want to be able to take those stream sources and land them in these Fabric destinations. So we've introduced event streams, which is taking the power of event hubs and stream analytics, putting them together, and adding them to a Microsoft Fabric. So event streams in Microsoft Fabric is one stop to capture, transform, and route real-time event stream data to destinations in Microsoft Fabric with a no-code experience. It'll be a centralized place for event streams. So all of it's the source for all of your event data. We'll have scalable infrastructure, so you don't have to worry about scaling each of the components separately. It's all part of the Microsoft Fabric capacity. It'll handle event capturing, transforming, and routing. And then you can ingest from streaming sources. You can ingest from a custom application. So because we've embedded event hubs as a component of Microsoft Fabric, you can now take your client that's speaking AMQP or Kafka and talk directly to Microsoft Fabric. We'll provide an endpoint for you to consume and then take your, for example, your Kafka API, Liberty Kafka, that's pointing to a Kafka cluster. Now just point it at the Microsoft Fabric endpoint, and you can continue to work without any code changes. We'll be able to consume from Azure resources, such as in Event Hubs in Azure or an Azure IoT Hub. And we'll also provide a rich set of sample data so that you can try out your event streams as you're building it out. We'll have a no-code experience, so it'll be a drag and drop experience, make it super simple to utilize and create these event streams. Be familiar and intuitive, consistent with the rest of the way that Fabric works. And it'll give you end-to-end data visibility. So you'll get monitoring and insights to the events all through each of the steps in that no-code experience. We'll also provide event routing to Trident entities. So in real time, we have the KQL database, which is a fantastic database for doing real-time indexing of your data at high speeds and high throughputs. We'll also be able to send the events to a lakehouse for DW analysis. As part of that sending to the lakehouse, we'll automatically transform those events into Delta Lake. You can send it to Power BI for real-time reporting. And we'll continue to extend those destinations. Now let's see what we can do with the new Fabric event streams. I'm going to show a demo of taxi drive data as it comes into the event stream and then gets pushed to various destinations in Microsoft Fabric.
Event streams provides you with a one-stop to capture, transform, and route event stream data to various destinations in desired format with a no-code experience. In your Trident workspace, go to Real-Time Analytics and create an event stream. Give it a name, and in just 3 clicks, you land into this no-code and easy-to-use experience where you can configure your event stream from source to destination. There are 3 sources available for you to choose from: sample data, Azure Event Hubs, and custom app. And for your destination, there are 3 destinations: custom app, lakehouse, and KQL database. I'll select sample data and select from the existing sample data set, which is yellow taxi or stock market. So I give this a name and create the source. The source is created. The data starts flowing in your event stream through the sample data. Let's add another source, which is Azure Event Hub. This lets me connect to an existing event hub in Azure to get the data into this event stream in real time. To get data from existing Azure Event Hub, I need to just give a name, need to make a cloud connection, select my data format, and the consumer group. This is an Azure Event Hub, which is actually sending a toll booth data, and I'm going to connect my Trident event stream to that Azure Event Hub. So I click Create. Azure Event Hub source is now created and ingesting data into my event stream. It's a toll booth data, so it shows me entry time, car model, state, toll amount, etc. And I can also see some data insights, as in if there are any errors or any data conversion issues or any delay that's happening. I can also see how many input events are coming in, how many events that are going out. Now let's configure another source, which is a custom app. Give it a name and create. The custom app source is created for event stream. This will enable a streaming endpoint where you can point your existing event hub or Kafka clients to your event stream without doing any code changes. Now I have 3 sources streaming into my event stream. Let me delete the yellow taxi source. Now let's create a new destination, which is Lakehouse. I give my source name, select the workspace, the Lakehouse, select existing table or create a new Delta table, select the data format as JSON. But before writing any data to my selected Delta table, I want to actually transform my data. So I open the processing editor, and here you can see the event stream going into Lakehouse and the various transformations available to me. There's aggregate, expand, filter, group by, manage fields, and union. For this demo, I will be combining 2 transformations, which is filter and manage fields. So here I have combined 2 transformations, filter and manage fields. The car data that's coming in from a toll booth has the car model, state, toll amount, etc. As you can see, various types of makes and models in the data, but I just want the data for Honda. So I filter it on the make equals Honda. And then after that, I do not want all the columns to go into my Delta table. So I do manage fields and I select these 3 columns after renaming them. So I just want the state, the toll amount, and the license plate of all the Hondas that are going. And then I will send it into my selected Delta table. They save and then create my Lakehouse destination. With Lakehouse destination, you can see that you can transform your real-time events before ingesting into your Lakehouse. And these real-time events are converted into Delta Lake format and then stored in the selected Lakehouse table. The destination is added and you can immediately see the preview insights into if events are coming in, if there are any backlogged events, any delay that's happening. So as you can see, there is no delay and events are flowing in as well. So if I go into my Lakehouse, I had created this table and these are the 3 columns that I'm sending. I can immediately see that the data has started coming into my created Delta table. Now let's create another destination, which is KQL database. I give a destination name, select my workspace and also the database from that workspace and create. This lands me into ingestion data wizard where I can either select an existing table from the selected database or create a new table. So let's create a new table. And then I check my source and the schema. So here I start seeing the schema of my incoming data, which is the toll booth data. I select my data format as JSON. And since there was some nesting, so I selected 1 level of nesting. And then I go to the summary and the data connection has been established. The KQL database destination has been set up. If I navigate to my KQL database and the table that I had just created, I can actually see that there is data coming in. When was the last ingestion? What was the size? And also the schema. I can run pre-created Kusto queries on top of my incoming data. And this is a very easy way for me to get my real-time data through event stream into KQL database. Let's add another destination, which is custom app. I give a name and create. This destination creates a consumer group, which you can then use to connect to your custom applications to your event stream. So as you can see, it was super easy for me to create this event stream from source to destination, from custom app or event hub or my sample data to Lakehouse with transformation, or I can do a bulk import to KQL database, or I can use a custom app to connect to custom applications. Thanks for watching.
So what you saw is the ability to ingest millions of events into Microsoft Fabric and be able to process that and handle that as it goes into the different lakehouses and KQL databases, and then be able to create reports off of those things, all in Microsoft Fabric in a single unified experience. So what you've seen today is a number of updates that we're providing at Build across our suite of messaging services. We hope you're going to be able to try them out and have a great, excellent build. Thank you.